We're surrounded by smart devices. They're in our homes, our cars, our workplaces. They're literally everywhere. They make our lives so much easier, but they also create this massive security challenge. But what if I told you that the very way we hunt for hidden bugs in these devices is, well, it's fundamentally, catastrophically broken?
Yeah, think about it. Your smartwatch, that thermostat on the wall, maybe even the coffee maker you can start with your phone. The invisible software that runs these gadgets, the actual brain of the device, it has a deep-seated problem that makes finding security flaws incredibly difficult before it ends up in your home.
So what is the software we're talking about? It's called firmware. And no, it's not like an app you can just install or delete. This stuff is the core operating system of the device, programmed right into its memory. It controls everything, from reading a tiny sensor to connecting to your Wi-Fi. It's the essential link between the physical hardware and the job it's supposed to do.
Now, testing this firmware is exceptionally hard. See, unlike your laptop, which has a pretty standard design, these embedded systems are like the Wild West. All kinds of custom hardware and unique software. But the real challenge, the real kicker, they're not just doing one thing at a time. They're constantly juggling inputs from dozens of sources at once. Sensors, network data, you pressing a button, it's a nonstop, chaotic symphony of information.
And all that constant juggling, it creates a massive problem for our best bug hunting tools. It's a phenomenon that researchers have named the avalanche effect. And believe me, it is the core reason why our old-school methods are failing to keep our smart devices secure. So how do security researchers even hunt for these bugs in the first place? Well, one of the most powerful techniques out there is called fuzzing. You can basically imagine it as an automated system that just throws millions of pieces of random, slightly broken data at a program just to see what makes it crash or act weird. It's an incredibly effective way to find hidden flaws. But when it comes to firmware, there's a serious catch.
And here it is. This is the absolute heart of the problem. A normal program, let's say a photo viewer, processes a single predictable input. It just opens the file from start to finish. Simple. But firmware is constantly getting interrupted. It might be processing a Wi-Fi signal, then get stopped to read a temperature sensor, then get interrupted again because you pressed a button. Its input isn't a straight line. It's a chaotic, jumbled-up stream of data from all over the place.
For years, the way we tried to test this was to just take all that chaos and flatten it into one long line of data. You'd take a sensor reading, then a 3D printer command, then another sensor reading, and just string them all together. It kind of seemed logical because that's how you'd test simpler software. But for firmware, this method is a disaster waiting to happen.
And here's why it all falls apart. The fuzzer does its job. It makes one tiny change. It flips a single bit in that first sensor reading, hoping to trigger a bug. This is standard procedure. Just a totally normal way to test for vulnerabilities. But that one tiny change, it triggers a devastating avalanche. Because the firmware now reads that first input differently, its entire behavior gets thrown off. Suddenly, what was supposed to be a perfectly structured 3D printer command is now seen as complete junk. Everything that comes after it becomes meaningless garbage, and just like that, the entire test is instantly ruined.
As the researchers themselves put it, a simple mutation can completely discard any progress the fuzzer has made. It's like trying to build a house of cards. You make one tiny adjustment to a card at the bottom, and the whole thing just collapses. That's the avalanche effect.
So if flattening the input just creates an avalanche, what's the solution? Well, we need a much smarter approach, one that organizes the chaos instead of just ignoring it. And that is exactly what this new research has given us.
The core idea is just powerfully simple. Instead of forcing all these different types of data into one jumbled, fragile line, the solution is to separate them. You have to acknowledge that the data comes from different sources and then treat each one on its own terms. This is the multi-stream approach. It's a three-step process. First, the system automatically figures out every unique source of data the firmware is listening to. Wi-Fi, sensors, user controls, you name it. Second, it separates the data from each source into its own protected stream. And third, this is the magic part. The fuzzer can now test and mess with each stream on its own without causing that destructive avalanche effect on all the others.
And the difference this makes is just night and day. The old flat input method is fragile, it's opaque, meaning you can't tell what's what, and ultimately, it's really ineffective. The new multi-stream approach, it's stable because a change in one stream doesn't break the others. It's typed, which is just a fancy way of saying the fuzzer knows what kind of data is in each stream, and because of that, it is dramatically more effective. So, based on this idea, the researchers built a brand new fuzzing tool. They called it Hoedur, and when they unleashed it on real-world device firmware, well, the results were nothing short of stunning.
First off, get this.
Hoedur discovered 23 brand new, previously unknown security bugs. Some of these were found in firmware that had already been extensively tested by other tools. The bugs were just hiding in plain sight, completely invisible to the old methods.
Second, it was way more thorough. There's a metric called code coverage that measures how much of a program's code a test actually reaches. Hoedur explored up to 5 times more of the firmware's code than the best tools out there. That means it was looking in corners no one had even been able to look in before.
And finally, this one is just incredible. It's speed. When tasked with finding bugs that we already knew about, Hoedur found them up to 550 times faster. Let that sink in. 550 times faster. That's the difference between finding a critical security flaw in minutes versus days or even weeks. It's a total game changer.
I mean, these results are a huge leap forward. But what does a faster, smarter bug hunting tool actually mean for you and for all the smart devices you rely on every single day?
So let's just quickly recap the whole thing. The old way of testing the software on our smart devices is fundamentally broken because of this avalanche effect. But by intelligently organizing all the device's inputs into separate, independent streams, we can finally test these complex systems the right way. And the result is a tool that finds more security bugs and finds them hundreds of times faster.
Look, at the end of the day, this isn't just some clever piece of computer science. It's a vital tool for making our increasingly connected world safer. From the smart thermostat on your wall to the complex systems running our power grids, this new approach gives security experts a real fighting chance to find and fix critical flaws before they can be exploited by the bad guys.
And this leaves us with a pretty critical question, doesn't it? We are building a smarter world at a breathtaking pace. But this research shows our security tools have been struggling to keep up. So as we move forward, how do we make sure our technology is not just smart in its features, but truly smart about security?